Hello guys, welcome to the LearnBot. In this video, I am explaining the ultrasonic sensor for distance measurement. Ultrasonic sensors are common in robotic applications such as obstacle detection and avoidance. Ultrasonic sensors can measure distance with aid of ultra-frequency sound waves. It has two components, transmitter that sends out a burst of sound wave and a receiver that waits for the reflected wave. We can calculate the distance to obstacle by measuring the time elapsed between the transmission and the bounce back. Then the distance is equal to the speed of sound into time elapsed for traveling this wave divided by 2. We need to divide this by 2 because this time accounts for the both transmission and the receiving. HC-SR04 is a commonly used affordable ultrasonic ranging sensor. It is effective in measuring distance from 2 cm to 400 cm with a resolution of 0.3 cm. It has a conical field of measurement with an angle of 30 degrees. 5-volt supply should be connected to the VCC pin and the ground pin. When a pulse width of 10 microseconds is given to the trigger pin, the transmitter emits 8 pulses of 40 kHz sound wave. After sending the sound wave, the receiver waits for the bounce back wave. Until the receiver gets the bounce back wave, the state of the echo pin will be high. When the bounce back wave hits the receiver, the echo pin changes to the low state. Therefore, the time for traveling the sound wave in the full course, that is from Tx to object then back to the Rx, can be measured from measuring the time where the state of the echo pin is high. Now I am going to explain these things using a HC SR04 ultrasonic sensor. Here we have the HC SR05 ultrasonic module. Here you can see the transmitter and here you can see the receiver. Then this is the VCC pin, trigger pin, next the echo pin, finally the ground. Now I am going to connect this with an Arduino. I am going to use this Arduino Uno controller. So first I am connecting the VCC. So we need to connect this VCC to 5 volt of the Arduino. Then the next pin is the trigger pin. So now I am connecting the trigger pin. Let's say we connect it to pin number 4. Then I am connecting the echo pin. We'll connect it to pin number 2. Then finally the ground. We need to connect it to the ground of the Arduino. So now we have completed the circuit. Now it's time to program this Arduino to measure the distances using this ultrasonic sensor. Let's program the Arduino to measure the distance using the ultrasonic sensor. First we can define the pin numbers. Define echo pin. We have connected echo pin to pin number 2. Then we can define the pin number of trigger pin. We have connected trigger pin to pin number 4. Then we need to define variables for distance and also for the elapsed time. For distance, we can use a variable type, let's say integer. Then elapsed time, we can use a long variable type because elapsed time is measured in microseconds, so we may have large values which overflow the integer, so it is better to use long. So for the elapsed time, I am using variable type long. Then we need to define the pin mode of the pin number 2 and pin number 4. We can use the pin mode command. Trigger pin should be an output. Then the next pin, echo pin. Echo pin should be an input. To visualize this distance measurement, I am going to use the serial monitor. So I am using the serial begin command for enabling that communication. Within this loop structure, we can write the code for the distance measurement. To initiate the distance measurement, we need to give a high pulse for the trigger pin, which lasted for 10 microseconds. For that, we need to set the trigger pin to high state. We can use the digital write command. Then we need to maintain this high state for 10 microseconds. For that, we can use the delay microsecond command. 10 microseconds. After 10 microseconds, we need to set this trigger pin back to low state. After execution of this line, the transmitter of the sensor will send a burst of ultrasonic wave, and the receiver will wait until it receives the reflection. Until receiving the reflection, the pin state of the echo pin will be high, and after receiving it will change to low. We need to measure this duration. To measure this duration, we can use the command pulsing. So I am now going to use that. Elapsed time, and define elapsed time equal pulse in, pin is echo pin. Then here we need to set whether we are going to measure the high state duration or low state duration. Since we are going to measure the high state duration, we can use high here. This elapsed time will be in microseconds. Then we can calculate the distance. Distance equals to elapsed time. This elapsed time is in microseconds. So we need to convert it to second by multiplying it 0.0001. Now it is in seconds. Now we need to give the speed of the sound, 340 meters per second divided by 2. Now this distance value is in meters. I am going to convert it to centimeters by multiplying again by 100. To display this distance measurement, I am going to use the serial monitor. So now I am adding command for that purpose. Now we have completed the program. Now I am uploading it to the Arduino. Oh, there is a error, some typo. I will correct it. Now I think it will. Okay, we have uploaded the code to the Arduino. Let's do some experiment to see the distance readings. Here I have attached the ultrasonic sensor to here, and now from the PC we can measure the distance. In here I have kept a tape to compare the readings. Now this obstacle is in 10. Our reading also 10. Now I am moving it further. Now 15. Let's see the reading. It is 15. Now I'll move it to something value like 24. Let's see. It is varied in between, sometimes 23, 24. There may be error like 1-2 centimeters in this sensor. Now I am moving into 30. We got the reading 30. Likewise, we can continue this for like up to 2-3 meters using this sensor. So now I am trying a smaller value like 8 centimeters. We get the correct reading. Then to 6. The reading is correct, varying between 6-5 sometimes. Now to 4 centimeters is still correct. Now 3 centimeters, we get the correct reading. Now 2 centimeters. Now still most of the time we get 3, but it is varying between 2 and 3. Now I move it further close. Now suddenly you can see readings are wrong because it has a minimum value for the readings. So for this sensor we can measure close distances. The minimum distances is around 3 centimeters. I hope you enjoyed this experiment. In this video I have explained how to use a ultrasonic sensor with an Arduino and do the distance measurement. Then I have done an experiment to explain our work. Hope you have enjoyed the video. Thank you. Please subscribe our channel Learn to learn robotic related stuff.